Thank you for your kind patience. It is now time to get started. So we would like to start our presentation on Fujitsu's initiatives on the area of physical AI. Today, once again, thank you very much for taking your precious time to attend our session. Let us brief you on the structure of today's presentation. Today, we will have a short presentation for approximately 20 minutes, followed by questions and answer for about 25 minutes, followed by a demonstration session for another 45 minutes. We will be ending at around 2:30 p.m. local time. The moderator will be Saito from the Public Relations IR room. We will now start the presentation. The presenter is the head of physical AI, Genta Suzuki from Fujitsu and Fujitsu Research. So now, Mr. Suzuki, the floor is yours. So thank you very much. I am Genta Suzuki from the Physical AI Laboratory at Fujitsu Laboratories. And first, I would like to explain about our studio where you are visiting today. This is the Physical AI Studio. This is a room designed to simulate the on-site deployment of physical AI. So it is a place to demonstrate and simulate before we roll out to the world. And we use these projectors. We create real-world environments such as warehouses and other logistics areas. And we also conduct robot experiments and interact with humans. And we will be able to see how humans will be feeling on working together with robots in such an environment. So this physical AI, when we look at robots until now, they have been entities that perform predetermined tasks in specially prepared environments in advance. But today, in the era of physical AI, versatile robots that adapt to various human living spaces and AI that acts and adapts with physical capabilities will enable autonomous work, even in environments close to where people are present or in areas where humans cannot enter. And as a result, this kind of technology is expected to contribute to solving social challenges such as addressing labor shortages and also improving safety in working environments. In fact, Fujitsu has a long history in robotics. From the 1980s, Fujitsu Laboratories developed robots for extreme environments and space explorations, and in the 2000s, the company launched Japan's first commercially available small-scale research humanoid robot. And after 2005, we have launched the service robot Enon and also RoboP, which are mediator robots. And in recent years, we have shifted our focus from simply building robots to developing the AI that powers them. And we are advancing our research and development under the concept of human-robot collaboration and coexistence. In January of this year, in the International CES 2026, which is the largest trade show of this sort in the world, Fujitsu exhibited one of the world's largest technology conferences. For the first time in 14 years, we were introduced a spatial world model that embodies this concept. This technology integrates cameras in the environment with the robot's own cameras to accurately understand the space. Based on the captured information, it anticipates what will happen next and enables the robot to move proactively to assist people in the field. So we envision a world where people and robots coexist and collaborate safely in a wide variety of work environments. As robots continue to evolve based on the knowledge gained on the job, and as the result of this evolution are shared beyond individual workplaces and tasks, collaboration will become even more sophisticated. To realize this vision, Fujitsu is advancing the research and development of the Fujitsu Kozuchi Physical OS. Our goal is to create an operating system that enables diverse robots to collaborate within a given spatial context. So in this spatial operating system, we are developing two types of intelligence. One is the brain intelligence on the robot side itself, and the other is the world intelligence on the environment side to support the safe and accurate execution of tasks by robots and their collaboration with humans. This will enable the performance of advanced tasks that were previously difficult to do, as well as coordination among multiple robots. And we will combine these technologies with security, safety, computing, and networking to provide a full stack solution. So this is the overview of the Kozuchi Physical OS. So generally speaking, with an operating system, it is a mediator between the hardware and software. But with this Fujitsu Kozuchi Physical OS, we are able to adapt to the variety of needs in the field, and we are also able to absorb the needs of the tasks required in the field. So in the IT area, we have AI agent and also operation applications, and also all based on the directions from the users. The Takane, which is a domain-specific LLM, understands in business and context and generates robot tasks. And in this process, the system automatically selects the option combination of robots within the space and coordinates their actions without the user having to be aware of it. Next, in using world intelligence, it integrates information from cameras, sensors, and simulations to provide environmental data that enables the robot to move safely and accurately. So when the robot is moving, the robot knows how to make the move at what kind of strengths, and that way the robot is able to move around safely and more accurately. And also looking at the brain intelligence on the robot side, utilizing the memory, environmental adaptation, and also from simulation with humans, the robot are enabled to learn and perform tasks even while in operations. This Fujitsu Kozuchi Physical OS enables coordinated operation of multiple robots to improve productivity in manufacturing and also in logistics facilities, and facilitate safe and efficient human-robot collaboration at construction sites as well. So this is able to improve productivity in manufacturing logistic facilities and facilitate safe and efficient human-robot collaboration and construction sites. And in the main head office campus, we will also be rolling out this Fujitsu Kozuchi AI. And so this is the image of what it looks like. So on the campus, robots on the premises will work together to assist visitors by guiding them or providing security as needed to create a physical AI environment where robots naturally coexist with people.
And here's a technology roadmap. By 2026, we will demonstrate Fujitsu Kozuchi Physical OS version 1, including technologies, and we will showcase later in the demo across multiple sectors and release an SDK. Towards 2030, we will realize the expansion of robot skills independent of specific models. And today, out of the Kozuchi Physical OS, we are going to introduce some elemental technologies, how robot and humans can collaborate in the town. And also at the entrance, you will see Sim to Real, a technology that bridges the gap between simulation and reality, along with new imitation learning technologies. Sim to Real enable advanced tasks that the robot can adapt to the actual situation and carry the load without dropping it. And then without using the special center, but actually angles of the robots of the joints, we can optimize the robot movement. In this example, the carrying or adapting to flexible objects, such as opening the zipper, you need to really sense the movement of the flexible textiles, but that has been previously difficult for robots, but without relying on the sensors, we were able to adapt the force sensors. And in the presentation room, we will also explain 3D scene reconstruction using on-site cameras and domain-specific Takane. And from now on, we'd like to introduce a new collaboration. Today, we established the Fujitsu Carnegie Mellon Physical AI Research Center, a joint research center with Carnegie Mellon University in Pennsylvania in the US. Carnegie Mellon University is a leading institution that has been at the forefront of physical AI for over 40 years, with a vision of integrating AI and robotics. And Fujitsu and the Carnegie Mellon University has a long history of collaboration. Since 1985, we had sent many researchers to Carnegie Mellon University as visiting researchers. In 2018, to promote the joint research, Fujitsu opened the Fujitsu Research of America Pittsburgh office in Pittsburgh. And our researchers are working in close collaboration with the university counterparts. In our joint research in recent years, we hosted joint workshops at leading conferences in the field of agentic AI and worked through joint research on multi-agent security. Now, a video message from Professor Marshall Ebel, Dean of the School of Computer Science at Carnegie Mellon University, a 3-minute message.
Hello, my name is Marshall Ebel. I'm the Dean of the School of Computer Science at Carnegie Mellon University. And I am delighted to join you today on the occasion of the launch of the Fujitsu Carnegie Mellon Physical AI Research Center. Let me first tell you a little bit about the School of Computer Science and Carnegie Mellon University. This is where the very first program in AI was created. It was called the Logic Theorist and was created in 1958. This is also where one of the first computer science department was opened back in 68. This is where the first robotics institute, the first robotics program in the nation, perhaps in the world, was created about 50 years ago. Fast forward a little bit to the 2000s. This is where the self-driving team from CMU won the DARPA self-driving car challenge, which launched the entire self-driving car industry with the technology, starting with the technology developed here at CMU. This is also where we created the first machine learning department, the first degree in computer vision, and the very first major in AI in the country. But one of the things that is really the hallmark of what we do in the School of Computer Science is this capacity to link the fundamental research to impact and applications to the real world. And this is where our relationship with Fujitsu is so important. Fujitsu has been a trusted partner with us in translating fundamental research into real-world applications across a wide range of topics for nearly now 30 years. Through that collaboration, we supported research in human-computer interaction, machine learning, civil and environmental engineering, robotics, and virtual reality. So I am pleased to join you today to take this collaboration to the next level, and this time to tackle the new technologies around physical AI, where the new AI world meets the old robotics world. And so this will be the Fujitsu Carnegie Mellon Physical AI Research Center, which will enable our researchers to collaborate with Fujitsu to develop a physical AI system designed to tackle real-world challenges. It will enable close collaboration with industry to inform and inspire new research directions to meet critical demand and real-world application. And finally, and importantly, it will leverage our new facility, the Robotics Innovation Center, which opened in February of this year. This new facility provides collaborative space to test physical AI in real-world environment on a scale and level of resources that is unprecedented. So with all of this combined, we will bring this collaboration with Fujitsu to the next level, again, linking the fundamental research at the university with the real-world application with Fujitsu. Thank you.
we established Collaborative Research Center where 13 professors are involved. Through joint research with professors from organizations such as the Robotics Institute, Language Technologies, and the Machine Learning Institute, we will work closely together to advance research in areas to Fujitsu Kozuchi Physical OS and other areas. Now, I'd like to introduce some examples of the research with those professors. And this is related to brain intelligence. The video on the left shows the work of the Professor Sebastian Siller. In an underground environment where GPS signals do not reach, and this team won in the autonomous drone navigation. And this video is a result of the Professor Jean O, and to collaborate harmoniously in accordance with human values. And this humans and robots work together on a creative process of painting. Fujitsu Kozuchi Physical OS is also adapting such technologies. And regarding world intelligence, Professor Fernando de la Torres' team, as shown here, the red questions and the questions on the world, and they can answer this question by understanding the meaning of the world. And this precise understanding is also the knowledge obtained through these projects. And this collaborative research center, as was mentioned, at Carnegie Mellon University opened Robotics Innovation Center in February of this year to conduct the large-scale experiments and collaborative research creation. Now, let's enter the Innovation Center. This is a reconstruction using our technology, this Robotics Innovation Center. And the Robotics Innovation Center is about 14,000 square meters, a massive site. So space is quite broad and ceiling is also very high. Multiple robots can collaborate and also fly drones. And outside the building, there is also massive space. For example, we are able to conduct experiments simulating scenarios such as disaster relief. We also have a massive water tank, so you can also verify the underwater drones in the ocean, not only by sight and the premises. Various universities and companies can also engage in experiments for co-creation. So we like to push collaborative research using this center. Last but not least, we will progressively integrate the research findings from the Fujitsu Carnegie Mellon Physical AI Research Center into Fujitsu Kozuchi Physical OS to accelerate its early implementation in society. That is all from my side. Thank you very much.